Hey boys and girls, we are going to talk about subtracting decimals now. I am going to be looking in your book. If you want to look along with me, that's fine. I'm going to be in your module 10 through 20 book on page 357. All right, so yesterday we talked about adding decimals and how we were regrouping and representing that when we were numerically adding those numbers. Today we're going to do the same thing, but we're going to be doing it with subtracting. All right, so I'm going to look at number 8 on page 357. And again, we are going to continue to practice saying these numbers. All right, so this, you could say 6/10 or 60 hundredths. Subtract 38 hundredths. There's no need to say 0 and 38 hundredths because, that kind of doesn't make sense. If we were asking our parents for 38 cents, we wouldn't say, can I have $0.38? We just need to represent what's really there. So when we are subtracting, now this is something that you've talked about for a long, long time. But I want you to understand what it is you're doing. Subtracting is not just taking something and putting something new there when you have to regroup. There's a reason behind it. Just like we saw when we represented subtracting with our models. That's why that is pretty helpful because we're actually seeing what's being taken away. That's why that's a good practice for us to have. All right, so when I look here, I have no hundredths. But I'm supposed to take away 8 hundredths from that. But the thing is, I might not have any hundredths, but I have 6/10. If I have 6/10, I've got a lot of hundredths built inside of those tenths. So I can take away a tenth from there, and that is going to give me my 10 hundredths, just like you can visualize in those pictures like we've been doing. 10 of those hundredths represents that 1/10. So now that I did that, just like we would in our picture, we marked it out. That's all we're doing. So 10 hundredths minus 8 hundredths is 2 hundredths. 5/10 minus 3/10 is 2/10. Don't forget that decimal. 0 minus 0 is 0. Okay? The answer, we would say that 22 hundredths. We had forgotten to put our decimal there. That would be the number 22. And that wouldn't make any sense at all. If we're thinking about it like money, if I had 60 cents and I spent 38 cents, would I have $22? No way. I'd have 22 cents, 22 hundredths. 22 hundredths of a dollar. A dollar is 100. I'd have 22 of those. All right. Let's look at number 9, and I'm going to write it a little differently than what you see it in your book. Okay? And when we're doing problems, a lot of times we're going to see our problems either written this way, or we're going to have our numbers in word problems. So, when we're tested and we're doing these things, it's not going to just say, add these two, subtract these two. Very often we're reading a word problem and we're having to pull that information out. So it's very important for us to know how to write it out when we're doing it by ourselves. So we know that we've got our 27 and 4/10, and we're taking 9 and 13 hundredths away from that. So 27 and 4/10, we're taking away the 9. All right, here's a common mistake. 9 and 13 hundredths, okay? It happens all the time, every day. Answer choices that you have, a B, C, or D, solving it this way will be an answer choice almost every time because this is a common misconception whenever we're subtracting, okay? Again, it goes back to that place value. That's why we've been talking and saying and writing these numbers so much, because it's important for us to understand what they are, okay? So hopefully when you look at this, which is not correct. While I'm talking about it, I'll do that. This is 27. We know this 2 means 20. The value of this 2 is 20. The value of this 9 is 9. But when we're putting it here, it makes it look like the value of it is 90, and it's not. So we've got to make sure that we're lining it up where it makes sense. You know what? Let me just do that real quick too. I wanted to talk about our reasonableness. Let's say we did it this way, which is wrong, 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 wrong. This is wrong. 4 minus 3 is 1. 7 minus 1 is 6. 2 minus 9, can't do it, but most of the time what I see students do is flop it around and say 7. Okay? We know that what we had here at the beginning was 27. If I had 27 and I took away 9, 7 doesn't make sense. 7 isn't correct. If you did say, well, 2 minus 9 is a negative number and you got negative 7, then that makes even less sense if you refer back to what you originally had. If I have almost $30 and I take away $10, I'm going to have about $20. I'm not going to have 7. You know, that's where using that reasonableness is very important, because sometimes we can absolutely eliminate an answer. It's very easy for us to accidentally work our problem out like this. Happens all the time. But hopefully you get in the habit of saying, all right, wait a second, that does not make sense. Okay? So let's make it make sense. We have 27 and 4/10. So my 9, it belongs where? It belongs under that 7, because that is 1s and 9 is 1s. I have 13 hundredths, all right? So I'm going to put my subtraction mark. Now I remember when we were doing adding, we added a 0 as a placeholder here, but we saw when we added, we were just adding 0, it didn't make a difference, okay? In this case, though, it does make a huge difference. A common misconception is bringing that 3 straight down. That happens all the time. I see it all the time when we're starting to subtract. Now, let's talk about why that's incorrect. We're going to do it a few different ways. So, well, let me go ahead and finish it this way. So this is incorrect again. 4 minus 1 is 3. 7 minus 9. We'll talk about how we cannot, we don't have enough 1s here. But I know I have enough 10s that I can put 10 back over here with the 7 I already have. So 17 minus 9 is going to give us that 8. And then we'll bring down the 1. 1833 is what we got. Kind of makes sense, 1833. That was a reasonable one. So this is tricky, because if we do it this way, a lot of times our answers still make sense, but it is not the exact one. Now, you remember how last week we talked about when we subtracted, we could always add to check? So let's add to check. When I add these two, I should get this number. Let's do it and see. 6, 4, 17, 27. Look, it's so close, but I did not get my answer. So this is my sign that I didn't do it correctly. Okay? It's so close to being the right answer, but it's not exactly it. So that's a common mistake that a lot of times, even if you are being really good and you're trying to see if it makes sense, that answer still kind of made sense. All right? So let's talk about what we should do and why it's important. All right, well, first of all, here I've got my value on top. I add this 0 here because here is my 3 here. It's supposed to be being taken away from something. I'm supposed to be taking 3 hundredths away. I can't just bring it straight down. It's being removed from that number. When we drew those pictures, we were taking it away. But when we did it the other way, we left it there like it didn't matter. But it does. It really does. So that's why we're going to stick this 0 here, because we've got to remove the 3 hundredths from our value. So in this case, our other number didn't have hundredths as far as a digit sitting there. But if I have tenths, I have hundredths. Remember, when we had those tenths, if I had 4 tenths, that's 10, 20, 30, 40. I have 40 hundredths there. So I do have some. They're just not represented in the hundredths place. So I'm going to take away 10 of those and give it to my friends down here because they need some. Because they're needing to represent those hundredths that are left. So I'm going to have 7 hundredths left. 3 tenths and 1 tenth is going to be 2 tenths. Again, like we thought about a second ago. 7, the whole number 7, take away 9. I don't have enough ones here to do this, but I do know that in every group of 10, I have 10 ones. So if I take away 10 of those, now I just have a 1 there, but I'm putting them here. 17 minus 9 is going to give me my 8, and 1 minus 0 is 1. And I get 18 and 27 hundredths. Let's add to check. 7 plus 3 is 10. Carry my 1. 2, 3, 4. 9 and 8 is 17. 27. There we go. That is it. All right. So as we are borrowing, as you call it, or regrouping is a better way to put it, I try to explain it because that's what's happening. We're not just marking stuff out and putting a number there. There's a reason. And drawing those pictures that we did helps us to kind of see what we're doing. Then when we do it mathematically here, it helps us know what's happening. Okay, let's do one more. I don't want this to be too long. All right, we've got, for number 10, 34 and 6 tenths minus 8 and 72 hundredths. All right, I'm writing it like this again because I want you guys to write it correctly. So let's line it up on your paper. You do it while I'm doing it, and we're going to see if we did it the same. Okay. All right. So again, we're lining up these decimals, but more importantly, we're putting our ones with our ones, our tenths with our tenths. Hundredths, we don't have any hundredths here. Let's add that 0. Again, adding the 0 is not changing the value of this number. Now, we can't always just stick a 0 on the end of a number. You know, if I have $10 and you put another 0 there, that's $100. That's very, very different. You've changed the value. But in this case, I still have 6 tenths. Or you could call it 60 hundredths if you add that 0. But 60 hundredths is the same value as 6 tenths. So that's why it's okay to do that, because there are 0 hundredths here. It's okay. All right. So if we remember that, that's going to be a big step. Again, I don't have any hundredths represented here, but I know that 6 tenths has a lot of hundredths, 60 of them. So I'm going to borrow, and I'm going to make that just be 5 tenths. And I'm going to give those 10 little hundredths that I took away, I'm going to put right there. 10 minus 2 is 8. 5 tenths, take away 7 tenths. I don't have enough tenths right here, but I do know that 10 tenths is 1 whole. So I can take away this 1, make it a 3, and that's going to give me my 10 tenths. 10 tenths equals that 1. We saw that. So 15 minus 7 is 8. Again, 3 minus 8. 3 ones, take away 8 ones. I don't have enough ones, but I do have 10s. I know there are 10 ones inside of each 10. So if I take 10 of those away and give it to this guy, sorry, it's kind of sloppy. 13 minus 8 is 5. We're not taking anything away from that 2. We're going to get 2588. Only takes a second. Let's check and make sure we're right. Stick that right down there. 8 plus 2 is 10. 7 plus 1 is 8. 8 plus 8 is 16. 8, 9, 10, 11, 12, 13, 14, 34, and 6 tenths or 60 hundredths. It checks out. Always check it by adding. We seem to be able to add a little bit better. If it doesn't add up, then something has been wrong. All right.